Hello and welcome back to our channel, Camel Case. If you've been following along, you already know how important this video is. Previously, we have talked about SDLC models. Now, in this third video, we're delving about software testing technique even deeper into valuable techniques that can elevate your testing game. Whether you're a testing pro or just getting started, there's something insightful here for you. Let's jump right in. To begin with, let's discuss the concept of software testing techniques. Software testing technique refers to a systematic and structured approach used to evaluate and validate software applications. These techniques involve a set of practices, methods, and strategies aimed at identifying errors, verifying functionality, and ensuring the quality of the software. By employing different testing techniques, developers and testers can systematically assess various aspects of the software, enhancing its reliability and performance. Next, we'll discuss methods for conducting tests. Software testing methods encompass various strategies and approaches used to verify and validate software applications, aiming to detect flaws, ensure proper functioning, and improve overall software quality. These methods come in different types, each serving specific purposes and employing unique techniques. In essence, testing methods can be categorized into two main types: manual testing and automated testing. In this video, we will be talking about tools used for manual software testing. Manual testing is a software testing approach where human testers interact with a software application or system to execute test cases, identify defects, evaluate functionality, and ensure that it meets specified requirements. In manual testing, testers rely on their judgment, intuition, and expertise to explore the software and uncover issues that automated tests might miss. This method is commonly used for usability testing, exploratory testing, and early-stage testing where human observation and adaptability are essential. Fundamentally, there are three subtypes within the domain of manual testing tools, namely black box testing, white box testing, and gray box testing. Let's now proceed to explore black box testing techniques and their various types. Black box software testing is a type of software testing methodology where the tester examines the functionality of a software application without having detailed knowledge of its internal code or implementation. In other words, the tester treats the software as a black box, focusing solely on its inputs, outputs, and behavior, rather than its internal logic, data structures, or algorithms. Now, transition to the realm of black box testing techniques. Let's now proceed to explore functional techniques and their various types. Functional testing focuses on verifying that the software application or system functions correctly according to its specifications. It checks whether the software performs the functions it's supposed to. Exploratory testing can be used to uncover functional issues by allowing testers to interact with the software, explore its features, and identify any unexpected behaviors or defects. Functional software testing encompasses various methods and techniques to verify that a software application performs its intended functions correctly. Some common testing methods and techniques within the realm of functional testing include unit testing. This method involves testing individual components or units of code in isolation to ensure they work as expected. It's typically performed by developers and is a crucial part of the software development process. Integration testing. Integration testing checks the interactions between different components or modules to ensure that they integrate seamlessly. It verifies that data flows correctly between these components. System testing. System testing evaluates the entire software system as a whole to ensure that all components work together correctly. It focuses on verifying the system's functionality against its requirements. User acceptance testing. User acceptance testing involves end users testing the software to determine whether it meets their needs and requirements. Smoke testing. Smoke testing performs preliminary checks to ensure that the software's basic functionalities are working before proceeding with more extensive testing. Boundary testing examines how the software performs at the edges of its input ranges to detect any unexpected behavior. Now, let's transition to the next category. This category is non-functional testing. Non-functional testing, on the other hand, is concerned with the non-functional aspects of a system, such as performance, usability, security, scalability, and reliability. While exploratory testing primarily focuses on functionality, it may also reveal some non-functional issues during testing if testers encounter performance bottlenecks, usability problems, or security vulnerabilities while exploring the application. Performance testing. This category includes various types of testing aimed at evaluating how well a software system performs under different conditions. Some subcategories of performance testing are load testing, stress testing, scalability testing, and capacity testing. Usability testing, focusing on the user experience and user interface design to ensure that the software is user-friendly and intuitive. Compatibility testing, checking the software's compatibility with different devices, browsers, operating systems, and network environments to ensure it functions correctly across various platforms. Security testing. This involves assessing the security features and vulnerabilities of a software system. Types of security testing are penetration testing, vulnerability scanning, and security auditing. Exploratory testing involves testers exploring the software without predefined test cases, allowing them to discover issues in real time. Let's now delve into the topic of white box testing. White box testing, also known as structural testing or clear box testing, is a software testing technique that examines the internal structure, logic, and code of a software application. In white box testing, testers have detailed knowledge of the software's source code, architecture, and design. They use this knowledge to create test cases that assess the correctness of individual functions, statements, and program paths within the code. Now, let's explore the subdivisions. Maintenance testing can be classified within both black box testing and white box testing methodologies. Maintenance testing, also known as software maintenance testing, is a crucial phase in the software development lifecycle that focuses on verifying and validating software modifications and updates. This type of testing ensures that changes made to the existing software, whether it's bug fixes, enhancements, patches, or updates, do not introduce new defects or negatively impact the software's existing functionality. Next, we'll transition to the aspect of maintenance testing, that is, regression testing. Regression testing is a software testing process that verifies whether recent code changes to an application have adversely affected the existing functionality. Its primary purpose is to ensure that modifications, bug fixes, enhancements, or updates do not introduce new defects or cause unintended side effects in previously tested parts of the software. Regression testing involves rerunning existing test cases to confirm that the software still behaves as expected after changes have been made. Let's proceed to our final subject, which is gray box testing. Gray box testing is a software testing approach that combines elements of both black box testing and white box testing. In gray box testing, testers have partial knowledge of the internal workings, design, or architecture of the software application being tested, but they do not possess complete or detailed knowledge of its code. In conclusion, software testing techniques play a pivotal role in delivering high-quality software. Whether it's manual testing, automated testing, white box testing, black box testing, or a combination of these methods. Choosing the right technique depends on the specific project requirements and objectives. Effective testing helps identify and rectify issues early in the development cycle, reducing the cost of fixing defects later, enhancing user satisfaction, and ultimately contributing to the success of software projects. Continuous improvement in testing practices and the adoption of innovative approaches are crucial for staying competitive in the ever-evolving software industry. In the presented video, we've gained insights into various software testing techniques, including their classifications and subcategories. In our upcoming video, we will delve into the topic of CI/CD pipeline. If you found this content valuable and wish to expand your knowledge in the IT domain, kindly show your support by liking, commenting, and subscribing to our channel, Camel Case. This much for today's learning. Remember, in the realm of wisdom, we all have a role. Knowledge is the key to reaching our goal.